Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this lesson we will look at arrangements if repetition allowed and the partial questions that include both permutations and combinations. Let's see example. In how many ways these letters A, B, and C can be arranged if no letters are repeated. All right, there are three places. First place, there are three letters A, B, and C to fill up the place. Then we have three ways to do so. And since no letters are repeated, when we move on to second place, there are only two letters left. So we have two ways. And we move on to the third place. Now there's only one letter, so there is only one way. So to find out the number of ways for the arrangement, there will be 3 times 2 times 1. Or you can see it as 3 factorial. And the answer is 6. All right, so there are 6 ways to arrange these 3 letters. Now, if the repeated letters are allowed, what does it mean? Let's see, there are still 3 places. The first place, we can fill up either A, B, or C, right? So there are 3 ways to do so. Since the repeated letters are allowed, we can still use the letters A, B, and C. So there are still 3 ways to fill up the second place, right? Even the third place, there are 3 ways to do so. Hence, the number of ways for the arrangement would be 3 times 3 times 3. All right? Then it's 3 to power of 3, and the answer is 27. So we have total 27 ways to arrange the 3 letters here. Now let's see partial questions. This is the question from 2009, October, November, variant 6.1. Find how many numbers between 5,000 and 6,000 can be formed from the digits 1, 2, 3, 4, 5, and 6. Part 1, if no digits are repeated, or part 2, if repeated digits are allowed. All right, 5,000 and 6,000 is the restrictions. All right, to answer part 1, we have 6 digits here, 1, 2, 3, 4, 5, and 6. In order to have a number in between 5,000 and 6,000, it must be a 4-digit number. All right, and the first digit has to be 5 from these 6 digits available. All right, then since 5, it has to be on the first place. Now we can only choose from 1, 2, 3, 4, and 6. So when we move on to the second place, there are 5 ways to do so, to fill up the second place. All right, then we move on to the third place. There are only 4 more letters, in this case, 4 digits left to fill up the third place. And finally, the fourth place, there are only 3 digits left. So 3 ways. Hence, the number of arrangement or the number of ways will be given by 5 times 4 times 3. All right, so the answer will be 60. So 60 different ways to arrange a 4-digit number that is in between 5,000 and 6,000. And no digits are repeated. Okay, now we have a look at the questions, part 2. If digits repeated allowed. So we still have 4 places, and the first place must be a 5. All right. Okay, in order to consider the second place, now we still have 1, 2, 3, 4, 5, and 6. And because even though digit 5 has been used to fill out the first place, but since the repeated digits are allowed, we can still use the digit 5. All right, that means the second place, there are 6 ways to fill up. And even the third place, there are still 6 ways to fill up. And the fourth place, 6 ways to fill up. And hence, the number of arrangement or the number of ways that we have will be given by 6 times 6 times 6. All right, so 6 to power of 3, and the answer will be 216 ways. So what happened to the first digit 5 here? Because there is only one digit 5, so and we must have the digit 5 on the first place, then there will be one way. All right. So if 1 multiplied with 6 times 6 times 6 is still going to give you 216 ways. Now let's look at the next questions. So there are questions that include both permutation and combinations. And this is the past year question from May-June 2013, variant 6.1. 4 families go to a theme park together. Mr. and Mrs. Lin take their 2 children. Mr. O'Connell takes his 2 children. Mr. and Mrs. Ahmed take their 3 children. Mrs. Button takes her son. The 14 people all have to go through a turnstile, one at a time, to enter the theme park. Part 1. In how many different orders can the 14 people go through the turnstile if each family stays together? All right, different orders in this case is asking about permutations. So the arrangement is important. All right, the keyword is arrangement. So we're looking for the number of ways of the arrangement for this particular case where all 14 people go through the turnstile, but each family stays together. Okay, let's see the working for part 1. So 4 families. So first, there are 4 members of Miss Lin. So they must all stay together. And then O'Connell, there are 3. And Mr. and Mrs. Ahmed and their 3 children. So they are all together 5. And the Mrs. Button and her son. So there are 2. So to look at the number of ways for the arrangement, what do we have? Effectively, there are 1, 2, 3, 4 groups of people being arranged, and there will be 4 factorial ways for the arrangement. And at the same time, the 4 family of Lin will be able to arrange among themselves. Then they have 4 factorial ways. And the O'Connell also have 3 factorial ways to arrange among themselves. 5 Ahmed arrange among themselves, and Button will 2 of them will arrange among themselves. And by using multiplication rule, we multiply all of them together, and that will be the number of arrangements that we need. And the answer is given by 829440. All right. Now we look at the second question. In how many different orders, same thing, we are looking at the arrangement. Can the 8 children and 6 adults go through the turnstile if no 2 adults go consecutively? All right. So we are looking at the children. We consider children 1, 2, 3, 4, 5, 6, 7, and 8. So these 8 children, we try to look for the number of ways for them to be arranged. That means we have 8 factorial ways to arrange the 8 children. Now, in between the children, since we want to make sure that there are no 2 adults go consecutively, we will try to find the spaces in between the children. And we found there are 9 different spaces between the 8 children, and we can arrange the 6 adults in between. So the number of ways will be given by 9 different places, P, and 6 randomly select any 6 of them and arrange the 6 adults. All right, so that will be given by 9P6 ways. And same thing, we try to multiply them together, and the number of ways is going to be 2.44 times 10 to power of 9. All right, so that will be the answer for part 2. And now we have a look of part 3. Okay, once inside the theme park, the children go on the roller coaster. Each roller coaster car holds 3 people. Part 3, in how many different ways can the 8 children be divided into 2 groups of 3 and 1 group of 2 to go on the roller coaster? Okay, so this is looking for the, can be divided, and we're looking for the number of ways. So this is actually looking for selections, because we just need to select the children and put into groups, right? The arrangement is not important here. So to find out the number of ways for the selections, first we have 8 children and we select any 3 children from the 8. That will be given by 8C3 ways. Then these 3 children will form a group. And then there will be 5 children left. And from these 5 children, we select any 3 of them. Then the number of ways given by 5C3 ways. All right, then it forms the second group. Then the remaining 2 children, then we select both of them, and that will be the number of ways given by 2C2. And multiplication rule, we multiply them together, and that will be the number of ways we have of selecting 2 groups of 3 and 1 group of 2. And the number of ways is 560. All right, so that is the part 3 answer. All right, this question 3 is similar to the previous question we discussed and the question from May, June 2008. Please try these questions. Put your answer in the comment below. And don't forget to subscribe this channel and like this video. See you in the next lesson. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.